What is agency? What does it mean to act? If a wind blows and pushes a rock off a cliff, we wouldn't say that it was subject to a form of agency. We always have reserved agency to conscious life, and primarily to us human. Is this about to change?
Today, we're not talking about science fiction or AI takeover. We are talking about something much more practical and honestly much more disruptive. AI agents, not chatbots, not prompts, actual software doing work.
Welcome to the AI Brothers podcast. We are two brothers who have been discussing technology since we were kids and have decided to include you in these conversations.
We will cut through the noise to bring you data and research on the latest developments on AI. We're not interested in hype. We bring you the signal to keep you on top of this new technological and industrial revolution.
Because AI will permeate everything and be everywhere, initially as a layer on top of existing systems, and then become in itself the operating system.
Let's first set the scene. The word agent is overused. It's being used to describe everything from glorified chatbots that can call some tools to a system that can actually take actions in the world. A word that covers too many different things stops having meaning. So we're going to do this properly. We'll define what an AI agent is in engineering terms. Then we'll talk about research, what's working, what's failing, why evaluation is the bottleneck. Then we'll talk about business, where agents are actually being used, where they're not, and why the biggest agent deals are really about owning data, distribution, and workflow control.
Yeah, love this to set the scene, because we really want to build this from the ground up and start with good definitions. So let's start with a good definition of the word agency. So it basically covers three things. First, options. There has to be a space of possible actions. Second, selection. You need to be able to choose from these actions and not just randomly go for one of them. And third, which is probably the most critical, is responsibility, which means the world treats your choices as yours, which means people are attributing the outcomes to your decision. Now, humans have agency in a thick, messy way. It's a mix of intentions, values, regrets, social consequences. But until now, machines, they just don't have that type of agency. So for instance, a thermostat is not morally responsible for the heating bill. You're making the decision of what temperature you're going to heat your room. So when we say AI agents, we're not saying that a machine has human agency. We are looking at something much narrower, much more practical, a much more refined definition, which is a system that is built to choose and execute actions in a pursuit of a goal. So we have to be very specific. And the keyword here is execute. So the difference is a chatbot will talk, an agent will do.
So a good working definition of agency for a machine or an AI agent is an iterative loop that uses observations to select actions that change the environment. We shouldn't treat it like a metaphysical leap. It's an architectural move. A system qualifies as an agent if it can pursue a goal across multiple steps, choose actions, not just produce text, use tools, APIs, browsers, terminals, databases, internal functions, etc. Incorporate feedback, errors, test failures, policy constraints, and change in UI. If it doesn't do these things, it might be useful, but agent is marketing.
Yeah, so really, I think we need to start this episode with these good definitions. So another important definition is that an agent is not defined by autonomy, it's defined by action selection. You can have an agent that drafts a plan and ask a human to approve each step. It's still an agent. You can have an agent that run fully autonomously. It's also an agent. The difference is governance, not identity. So in one case, the governance of the agents is limited because it always requires human approval. In another one, in the second one, the governance is much more broad, requiring less human approval, because autonomy is not a virtue, it's the risk setting. It depends how you design your agent and how much tolerance for risk you have. Okay, now, so starting from these idealized definition, now let's transition to the reality. And whenever you go from ideal to reality, this is where it kind of kills the hype, because we've all seen these demos of agents and they look absolutely stunning. They're really impressive. But remember, these demos are single run. So it's a really straight path. It's predefined, probably selected in a certain way. In these demos, the agents gets one clean path, one curated task, and a narrator with it. That's why they look so impressive. But the problem businesses care about is not can it do it once. The problem is repeatability. Can it do it reliably across messy input, edge cases, and policy constraints? And if you read the agent's research seriously, it's basically saying the demos are great, but we're not as reliable as the demos suggest.
This is why evaluation is now the center of the field. And it is why so many of the latest research papers are not about bigger models. They're about better benchmarks. Because once agents interact with an environment, websites, terminals, CRMs, you get failures that aren't just wrong answers. You get a partially complete tasks, silent mistakes, policy violations, infinite loops, tools misuse, and the worst kind, plausible output that hides a bad action. So the agent question is less how smart is it, but more about how does it fail.
Yeah, I mean, exactly. So let's talk about this evaluation problem bluntly, and let's focus on this for a second. So in the classical LLM world, so the benchmark were mostly static, fixed prompt, fixed answers. The agents are not that. Agents are more dynamic. They take actions, they get feedback, they branch. Two runs from the same agents can diverge widely. That means that in order to train them, in order to benchmark them, you need this interactive environment and you need this stable scoring and constraints that mirror reality. So it's very, very complex. And actually talking about research, so a recent paper, and it's currently on archive if you want to look at it, it's titled Establishing Best Practices for Building Rigorous Agentic Benchmarks. So it's a collaboration for a top AI university. You got the MIT, you got Berkeley, Oxford, and others. And what they do, the whole paper is about introducing this agentic benchmark. So the author argue that because of these benchmark design, you could either under or overestimate an agent performance by up to 100% in relative terms. So it's a huge difference between, it's basically something completely right and completely wrong. And it gives a bit of context about the examples of how scoring quirks and weak identification can lead to this huge variability in benchmark performance. And when you think about it, it totally makes sense, because how would you be able to evaluate a successful task? You need reliability. It means that it needs to be successful across multiple runs. It needs to adhere to a certain policy. You need it to stay within the rules of your agent, of your company. You need security, which is a huge investment in the LLM world to just making sure the agent will resist to some unsafe prompt injection or unsafe use of tools. You need calibration. Does it know when it doesn't know? So if it go in the wrong way, it should be able to call into a human to ask for a correction. And it needs recoverability, which means that when it detects a mistake, and it's small mistakes, it can go back and then correct it and go forward. And you need to be able to evaluate all these things. It's just such a complex problem that goes beyond the simple LLM, where you can have a trainer that just talks to the chatbot and then evaluate the response. Just the the huge number of possible outcome makes it extremely difficult.
This is the reason why coding agents are the most advanced agents out there, because they are really good ways to benchmark coding and thus to define the actions of the agent.
Exactly. So because coding has been rationalized so much, and a lot of even interviews, when you go to a coding interview, there's a much more there's much well defined outcome for a successful code. You can benchmark this coding agent, but for everything else, it's a wild west. It's very difficult. Okay, now we talked about the definition, we talked about the benchmarking. Let's talk about what's happening in the business world and what type of deals are going on at the moment.
Well, from the business surveys, everyone is claiming to be building agents. As we discussed, we need to be careful with definitions. McKinsey, the State of AI Global Survey 2025, reports 62% of respondents says their organizations are at least experimenting with the AI agents, and 23% say they are scaling on agentic AI systems somewhere in the company. LangChain's State of Agents Engineering reports 57.3% of surveyed respondents say that they have agents in production, with another 30.4% actively developing with concrete plans to deploy them.
Again, as you said, we need to be careful with definition. So we have a lot of these are claims. Everybody's saying that they're building agents, but they don't have hard definition. So I think what we can extract is not agents are everywhere, but rather that a lot of people are doing pilot and there is some scaling happening. They still need to demonstrate reliability, governance, and integration with other business processes in the company. The deal landscape is also interesting because we introduced it at the beginning about what's happening in the deal landscape. When you look at the deals, you understand that the race is not about building the smartest agent, but rather about distribution, data, and control of the workflow. So when you look at Meta, Facebook acquiring the AI agent Manus for an estimated $2 to $3 billion, they explicitly want to use this agent and integrate it with their already existing products. When you look at Salesforce, it's even more interesting. So what they're making a bunch of deals. So they're acquiring Informatica, which they explicitly frame as building a trusted data foundation for powerful and responsible agentic AI. And what they say is that Informatica plus Salesforce will provide the critical foundation for autonomous agent to interpret, and act on trusted data. So this is the foundation. They understand that for their agents to be powerful, they need this foundation of quality data. They're also looking to create expanded partnership with OpenAI and Anthropic and power their Agent Force 360 platform. So this is the second layer, which is basically where they want to integrate these frontier model into their enterprise. And finally, they're also acquiring another company called Qualified, which is described as agentic AI marketing solution. So when you see the deal, you see a consistency where it's model supply through partnership, secure distribution through platform embedding, secure data foundation, catalog governance integration, and secure workflow foothold through domain agent products. So it's not hype. It needs like a complete strategy where this agentic model is not just about implementing this new tool. It's about really thinking through the whole business process and thinking about how these new AI models will integrate with the company's business process.
Yeah, to finish off, we need to talk about my favorite topic, compute. Agents need both cheap, fast, predictable inference, but also memory capacity. When you use a classical AI chatbot, a response is usually a single model call. An agent, on the other hand, is a loop. Plan, act, observe, revise, act again. That means many calls, longer contexts, more tools, interactions, and a lot more tokens. Memory is becoming more and more important. You can already see the shift in how chips are marketed. When Nvidia talks about the H200, it's largely about memory. Nvidia describes H200 as 141 gigabyte of HM3 memory at for 4.8 terabyte per second bandwidth, explicitly framing that as a big win for LLM and generative AI workloads. In terms of compute, I see the future of agentic AI branching into two directions. Data center accelerators, GPUs, and ASICs like TPU inferentia type chips to drive large-scale training and high-throughput inference. Edge accelerators, NPUs in phones and PCs to run smaller models locally when latency, privacy, or offline use matters a lot more.
I actually find the second point, the edge accelerator, the edge application, to be the most exciting. Because if you want an always on agent behavior with voice, personalization, instantaneous response, you cannot just wait for it to round trip to the cloud and come back for every tiny step. So the industry is really pushing NPUs into consumer hardware. For instance, when you see the latest Apple A17 Pro, it's widely reported to have a neural engine capable of up to 35 trillion operations per second.
I'm going to add an important correction people skip. The number of operations per second is not the whole story. It's a theoretical number under specific conditions. In the real world, for an agent workloads, you care about memory bandwidth. Can the bandwidth feed the model fast enough? RAM capacity, can the model fit locally? Power and thermal, can it run continuously without cooking the device? Or crucially, software stack, quantization, runtime, kernel fusion, caching, etc.
Okay. Now that we reviewed the facts, let's daydream for a second, and let's think about the future. Is all of this agent and this edge computing, is it heading to a world where you just don't have app anymore? You just have this block and that you control with your voice, and that has this master agent that does things.
I don't think this is a dream. I think it's a logical progression. My bet, the app won't disappear. It will be invisible because apps aren't icons. Apps are permissions, business logic, identity, payment rails, and APIs. The infrastructure does not evaporate just because you talk to a model. What will change is the surface area. Instead of you opening 5 apps and navigating through them, the agent does it for you. You can you only indicate the intentions, book this, move that, summarize, and reply. compare, and decide. The agent orchestrates tools behind the scenes. This is the reason why agent compute matter so much. It's both physics and economics. Latency, conversational systems feel dumb when they lag. Privacy, people don't want everything shipped in the cloud. Cost, cloud inference for every micro gets very expensive. Reliability, if the network drops, your assistant shouldn't break.
That's really, I find this really an interesting future. Actually, an exciting future. Anyway, on this high note, I think we can wrap the episode. I hope you enjoyed learning with us as much as we enjoyed learning with you. We wish you a good and productive day.